So I wanted to start off with some background information. Windmills generate electricity by transferring energies from wind to a turbine. We are looking further into the relationship between wind velocity in miles per hour, or mph, and the resulting electricity production in amperes, or you will hear me refer to as amps. For the windmill, measurements were taken on 25 randomly selected days. The data results in the predicted electricity production based on the amount of wind velocity. The constant refers to the Y value, or response variable, which in this case is the predicted electricity production. It is the response variable because the amount of electricity production is dependent on the wind velocity, which is the X value, or explanatory variable, which is right here. All we need to know for this problem are the coefficients and R squared, here and this one. We will be using the slope formula y hat equals mx plus b, or y hat equals a plus bx. The constant, or electricity production, will be the y-intercept of b, and the wind velocity will be the slope of m. The equation then reads y hat equals 0.24 times x plus 0.137, or in other words, the predicted electricity production, or y hat, equals 0.240 at wind velocity x plus 0.137. To determine how much electricity would be produced on a day with 25 mph of wind velocity compared to a day with 15 mph of wind velocity, we would plug in 25 and 15 into the equation as follows, right here. So it is y hat, not y, because it is the predicted values. And so y hat equals 25 times 0.24 plus 0.137, which equals 6.137. And the other equation is y hat equals 15 times 0.240 plus 0.137, which equals 3.737. To find the difference, we will subtract 3.737 from 6.137 to get y hat equals 2.4 amps, more on the 25 mph wind velocity day than on the 15 mph day. I also double checked my work by doing 25, finding the difference between 25 and 15, which is 10, and just multiplying that by the wind velocity, and I also got 2.4 amps there too. So when dealing with proportions, that means we are dealing with R squared. The R squared value is given to us in the data. R squared equals 0.873. So 0.873 is the explained proportion of the variation in electricity production to describe its linear relationship with wind velocity. Thanks.